missed her somewhere along the way. Do you see her?
No, I don't see her yet.
Okay, not a problem. And there you go. Let me go ahead and meet the people. There's Lucy. Lucy's coming in. Yes. Welcome, guys. Welcome, guys. Welcome, guys.
Morning, Jackie.
Good morning. How are you?
I'm fine, thank you.
Welcome. I'm welcoming people in.
All right, let me move to a better location.
Welcome, Lucy.
Thank you, Jackie.
You're welcome. Stabilizer. And guys, as we are settling into the meeting, I'm going to randomly on various people to state the reason as to what it is that they are looking for. As we're just getting guys to come in. If guys, I'm gonna pick on say Richard Onyango. Richard Onyango, what are you looking to get from this meeting today?
Thank you very much, Jackie. I'm looking towards getting to know so much about AI.
That's great. Then you've come to the right hands, I'll say. Monica and Lucy are definitely going to put you through everything that they've been learning in the past 6 months. They've come a really long way. They're going to be here to be asked questions. And we also have our expert in charge, Migotten Dede. He's here as well to answer any questions if people have anything to ask and to learn. It's absolutely amazing. When we've been getting ready for you, our wonderful people, it's been amazing to watch the girls and their instructor just go through what they've been learning for the past 6 months and then be able to put it in an hour's worth of work and actually really explain it well, such that a layman would be able to understand, what's going on. Okay. So we are packed here. We are at 37 thus far, and we are 4 minutes in. I will give it 2 minutes for people to settle down and, get your water, grab your tea. Remember, we have the chat functionality on this end. So if you have any questions you want to chat as they go, feel free then to use the chat functionality. Remember to go on mute, such that if you're not talking, so that we do not have a feedback or background, because the girls have amazing information. I'm going to say John Maura, I see you're not on mute. I think we are getting feedback from you, John Kabuya as well. So if you do not mind, guys, going on mute so that we can really get the gist of what the girls are going to have to tell us today. So we are 4 minutes in. I'm just going to give it 1 more minute so that we can go ahead and start. Right now we are at 38. Great capacity, guys, and it's going to be absolutely worth your time. And then I'll give the intro and we can go from there. I'm going to go ahead and hit the record button. So guys, just know I'm going to start recording now. Is that the 407 number? Am I getting feedback from 407? Is it 44735? Okay. That's not where that feedback is coming from. Somebody have a radio on in the background? Gaudencio, I hope I'm not butchering your name. Gaudencio, I think we're getting feedback from you.
Yeah,
Gaudencio,
thank you.
do you mind putting yourself on mute?
Okay, I will.
Thank you. Coach of analyst, I feel that we're getting feedback from you. Do you mind going on mute? Coach of analyst. Coach of analyst.
Oh, okay. So
okay, I went ahead and just muted her. All right, we are 6 minutes in. So I'm going to go ahead and we have 45 people on the call right now. I'm going to go ahead and introduce the session. And today we have our Lucy. Do you Lucy? Okay, I see you. I see Monica. Wait, do I see Monica as well? Perfect. So I see their faces. So today we have Lucy Wagaro and Monica Njaga. They are going to be taking us through data analysis, a critical component in machine learning. So this is what they've been learning, a part of what they've been learning actually over the first 6 months. They are going to walk you through the topic. What they're going to do is the introduction, what it's about, tell you a little bit about themselves. And then at the end of it all, what we can do, use the chat functionality. I'm going to look to go live on our Facebook community page. So just feel free to jot your questions down. What you can also do is just keep them in your mind as they keep going, just jot them down yourselves. And when they're done, then feel free to ask questions. We have Monica, we have Lucy, we have Migot, and we have myself. So with that said, guys, over to you. I'm going to hand it over to Monica and to Lucy. Please take over from here. And if you need me, just raise your hand.
Thank you so much, Jackie. Our viewers feel most welcome. Let me say my name is Lucy Achieng Wagoro, as Jackie has said. I define myself as a self-motivated individual who is passionate about achieving results. I've been working as a trainer, a programming trainer for the past 6 years at Ramogi Institute of Advanced Technology, training students on C++, C, internet programming, and database management system. I've also acted in the capacity of assistant dean of students, the dean of students, to coordinate, to plan the activities of the institute, and which also includes students' conduct and co-curriculum activities. In the past 6 months, I've been waking up by 1 a.m. to learn Python programming language and data science. And I am pleased to be here tonight to just share the little knowledge that I've learned through the past 6 months. So feel most welcome. I'll hand it over to Monica, who will introduce herself and also take us through the first slides. Monica, welcome.
All right, thank you so much, Lucy. And thank you so much, Jackie, for the introduction. I also want to recognize our tutor, Migot. Thank you so much for whatever you have done to enrich our lives this way. So my name is Monica Njaga, and I'm an IT consultant with over 10 years of data engineering experience. I have worked in the pharmaceutical industry, food and beverage, manufacturing industry, just to name a few. And in my 10 years, I have played key roles in the migration of master data and transactional data from legacy systems like Oracle, TIBCO, SQL, into SAP and into the Informatica product information management tool. I have as well migrated from on-premise, or played key roles in projects that have migrated from on-premise to the cloud solution, which is one of the buzzwords that everybody is hearing these days. Some of the key roles that I played in my key roles are loading data, production support, and I'll be sharing my profile on LinkedIn so you can follow up with me if you have any questions. So you may be wondering, why have you all those years of experience and now you're exploring data science? Guess what? It is my passion to know more about data and the backend efforts responsible for everything that we see on our user interface in all the apps that we are using in our daily lives. For example, Google, Amazon, YouTube. I'm sure each one of you has ventured into those. So apart from passion in data, I also mentor the youth whenever an opportunity introduces itself or presents itself. And I take great pleasure in doing that. And you might wonder why, what drives you to mentoring? I want to share a quote that I got from, I came across. It is by a recognized business and marketing innovator by the name of Ekaterina Walter. And I quote, "If you think you are too small to make an impact, try going to bed with a mosquito in the room." End of quote. So whenever the opportunity arises, just go out there, spread the light, light other candles, and yes. So without further ado, thank you so much, our viewers. I want to welcome you. Thank you for taking your time on a Valentine's Eve. And we'll be sharing with you what has become of us in the past 6 months. And buckle up and let's get on this flight. So if you allow me, I will go ahead and share my screen. And I'll share my screen. And I hope everyone is able to see my screen.
Yes.
Jackie, can I get a thumbs up?
Yeah.
Okay, thank you. So as Jackie mentioned, our topic for the day is data analysis, a critical component in machine learning. And it will be presented to you by none other than Monica Njaga and Lucy Wagoro. And on here, I have our LinkedIn information. I go by Monica Njaga on LinkedIn. And Lucy goes by Lucy Achieng Wagoro on LinkedIn. And should you ever want to reach us on GitHub, these are our GitHub accounts. So feel welcome, and yeah, welcome to the show. I hope you will learn something from this. So from our topic today, I would want us to familiarize ourselves with 3 buzzwords that you'll be hearing over and again in this presentation. So the first buzzword is data, and then there's data analysis, and then there's machine learning. So in my next slide, I'll be defining what data is. So what is data? Webster defines data as facts about something that can be used in calculating, reasoning, or planning. And Wikipedia further defines data as characteristics or information, usually numerical, that are collected through observations. In a more technical sense, data are sets of values, qualitative or quantitative, about one or more personal objects. And so how does all this come together? So I have a picture here, and this depicts exactly where data comes from. So data can come from quantities, information, graphs, measurements, observation, facts, and numbers. And I'm sure you all have 1 or 2 accounting friends who will tell you that numbers do not lie. And I'm also here to tell you today that when you have your data in the right shape and form, it does not lie. It will give you the information that you need for your decision making or whatever you need to do. And you may wonder, how do I contribute to data in any of this? Guess what? Today you made a good decision. You joined us on Zoom, and thank you for tuning in again. And you are contributing to the data pool unconsciously. How are you doing that? If Zoom was to take a dump of the data of everybody who logged in onto Zoom today, February 13, you would make statistics. So data is business as usual. In businesses, it is the sales orders, the purchase orders, and everything else that you do, a new item or new product that you launch in your line. So we have defined data, and now we're going to go ahead and define data analysis. This is the second buzzword that you'll be hearing over and again. Data analysis is a process of collecting, inspecting, cleansing, transforming, and modeling data with the goal of discovering useful information, informing conclusions, and supporting decision-making. I would like you to take a note of these 5 buzzwords because I will be explaining them later in details. So the buzzwords are collecting, inspecting, cleansing, transforming, and data modeling. So are there different types of data analysis? Yes, we do have different types of data analysis, and we have descriptive analysis. So this answers the question, what happened? And then we have diagnostic analysis, which answers the question, why did it happen? And then we have predictive analysis, which answers the question, what is likely to happen? And finally, we have prescriptive analysis, which is the frontier of data analysis, combining the insights from all previous analysis to determine the course of action to take in a current problem or decision. And in real life, so an example of what happened. So an example is, I'll give an example with Amazon because I love shopping on Amazon. I'm of the opinion if I can get it at my door, I don't need to go to the store to shop. So this, assuming you are Amazon and you're like, so what happened? We suddenly started in noticing a lot of orders, online orders. And why did that happen? So the reason for that happening is because there was a pandemic last year. We all know about the pandemic, and people were worried about, we didn't know a lot about how it spread, so people didn't really want to go into the stores. And what is likely to happen? If Amazon has its data together and they're able to analyze customer trends, they may as well just have the shoppers going online. So that explains what is likely to happen. Now, the prescriptive analysis is, so how can Amazon help at least mitigate or at least how would they help with all these new orders that are coming? So Amazon would probably, as an example, at a course of action would be introduce more fleet to introduce more cars in their fleet. And that way they're able to deliver the merchandise on time for their customers and even get more customers. So that's just a snippet on data analysis. And then I would like to walk us through the next buzzword, which is machine learning. And what is machine learning? So machine learning is the science of making computers learn and act like humans by feeding data and information without being explicitly programmed. So if you are like me, 6 months ago before I took this course, anytime I hear about computers, what comes to mind is, okay, somebody goes in, writes a code, tells it how to execute step by step. But now that I have done machine learning, it's a whole different ballgame. So what is machine learning, or what do computers do in machine learning? So the system learns on its own. And how does it learn? You give it data and it learns using what we call the training process. And then once it trains the data, we tell the system if the outcome is correct or not. And it is from this feedback that we give the computer that it then goes and tries to correct itself. And that is how it learns, so it can at least be able to predict and give us the expected output. I can tell you it won't be 100%, but at least trends have proved that it has been successful. So what are the different types of machine learning? So we have supervised, and then we have unsupervised, and then we have reinforcement. And I'll touch on this very briefly. So supervised learning, you have a set of data, and then you feed into your machine what the target should be. So for instance, if you have a number of flowers, you would give them the sepal length, the petal length, and you would tell it, I want you to make this a rose or a carnation. So you are feeding the computer data, and then it knows the target, and then you'll introduce a totally new target, and it should be able to tell what kind of a flower it is. In unsupervised learning, however, what you have is you're just feeding data to the computer. You're not telling it what you expect, but with time, it makes association and clusters the data, and it becomes smart enough to give you some results. So that's with unsupervised learning. With reinforcement, you also feed data to your computer, and then you give it an agent and a target. The work it should do, the machine should work towards going towards the target. And when it goes to the target, you reward the computer or your machine. And when it doesn't work towards the target, then you penalize it, and then it'll go through the process and try and get to the right place. So in my next slide, I will be talking about, so what are some of the real life applications of machine learning? Believe it or not, you have enjoyed machine learning throughout your, many years. And I'll give an example that is very known by everybody. We all have an email account. So an example of Google, how does Google even know of all the emails that you're getting, what it puts in your priority mail or what it puts in your social, and then there's another folder, sorry, I forget that. So this is all machine learning. It looks for different buzzwords and knows, oh, this one Monica doesn't like it. It most likely will go to advertisement or even her spam folder. So machine learning has been used over time to solve different problems. So like in face recognition, so this is one of the problems that has, this is one of the problems that is being solved using face recognition is solving crimes. And then we also have security. How, whenever you're crossing borders, the machine learning is able to pair and see, okay, is this person the same person that they say is crossing the border? So in this, please be at the right side of the law, because if you try to cross with somebody else, yeah, they'll catch you. Machine learning is out there looking out for the border patrol. And then there's also the Siri and Cortana. We all speak to Siri once in a while. So that's machine learning. It's able to, as you keep talking into Siri, or even when you're doing your search on Google, your phone is able to tell your voice, and then it's able to at least search whatever you need. And then in the healthcare industry, how is machine learning being used? This is making work so much easy for the doctors. As we know, diagnostics are made based on learning or looking at images like X-rays and MRIs. So machine learning, once you train it, it's able to take a new image and look against what it's already trained and tell, oh yeah, this is a diagnosis, or this person has this and this disease. And then in weather forecasting, that's how the weatherman is able to tell you, carry your umbrella tomorrow, it will be raining, or wear your boots, tomorrow it will be snowing. And then if you're like me, I was one time, or at least sometime last year, I got myself addicted to Netflix. And how do you, so the way, it's weird how when you're addicted to, or when you're watching Netflix, there are certain kind of shows that you watch. So, and when you log into Netflix next, it's already suggesting shows based on what you've been watching. So if it's love stories, then it will give you all these suggested viewers. So that's how it does. Your TV, or whenever you log into your Netflix account, it's already studying you, and that's how it's able to suggest all these new shows. So that's just a brief intro on how machine learning is working. And once we've already defined those, I want to welcome Lucy, and please keep those buzzwords because you'll be hearing them. So there's data analysis, and then there's the machine learning aspect. So Lucy, welcome and take it away.
Thank you, Monica, for taking us through the definition of those terms. Once again, our viewers, thank you so much. I want to take it from there, and I will start by explaining how machine learning and data analysis fit into the word AI. Somebody already said you really want to know about AI, so let me just start from there. Allow me to share my screen. Monica, kindly stop sharing so I'll be able to share.
Yeah, yes, thank you.
Jackie, kindly allow me to share. It is disabled.
Okay, go ahead and try again.
Thank you.
Yeah.
So how does data analysis and machine learning fit in with the buzzword of AI? AI stands for artificial intelligence, and AI defines the science and engineering of intelligent machines, especially intelligent computer programs, which are able to handle tasks like human and also make discernment like human beings. So in my left side, I have a diagram that shows deep learning, machine learning, and artificial intelligence. Deep learning is a technique for implementing machine learning, and machine learning is an approach to achieving artificial intelligence. And then deep learning is a subset of machine learning, whereas machine learning is a subset of artificial intelligence. So as we are trying to train our machine to learn, what we are trying to achieve is artificial intelligence. And then for our topic today, data analysis as a critical component of machine learning, I would want to go further in my next slide and explain how data analysis is a critical component in machine learning. How is data analysis a critical component in machine learning? Data analysis helps us to analyze the outcome and draw conclusions. So these conclusions give us visualization. The visualizations then help us to create reports, and it is the reports that helps us to come up with a real-life situation for final decision-making process, e.g. by legislatures, the CEOs, businesses, and stakeholders, and just the general public. Decision-making process is very key in everyday life, and we want to make right decisions. In all this, we are saying that the conclusions are the patterns we want to use in fitting our training, in fitting or training our model, so that it is able to learn trends and make future predictions, which is now machine learning. So without data analysis, it is not possible to come up with machine learning. So we start with analyzing data, and then we get to now have or train the machine to learn. The next thing I want to show is the rule of thumb in all this. We are saying in machine learning that the bigger the sample, the better the future predictions. Remember, we are trying to train our machine, and we are using data to train our machine. The more sample we give it, the more patterns the machine will learn, and so the machine will get to have accuracy in prediction of the future. And then in data migration, we are saying load more, load often. Why do we load more and load often? We are trying to capture any occurrence of errors and eliminate any error before we get to data production. And then the word that most people have come across, garbage in, garbage out. Remember, we are trying to train our machine. So if we feed our machine with garbage, the machine will give us the garbage. So we are going to be very careful that whenever we are training our machine, we don't train it to learn patterns that are garbage, because if it learns that, then that is what we will get. So now, how does all this process start and how does it end? Data analysis process begins at this level I am calling reality, the day-to-day activities. Monica said that even today, if Zoom is to collect data about its users, then we will form part of that data. So from the reality, we get to gather raw data, and then the raw data goes into data processing. So in the data processing, this is where we try to make our data in a format that can be fed into the computer. And then the next thing we do is we clean our data. And after we clean our data, we get to create models and algorithms, or we can go into what we call exploratory data analysis, where we are trying to check, like, did we really do good cleaning? Do we need to add more information to it? Is there anything that is lacking? And if we find that something is lacking, then we will come back to data processing level, and then we do the cleaning. And thank you. And we create models. And then from here, we are now able to communicate, to make visualization, and to create our reports. These reports are the ones that are helping us to make decisions. And still, from our models, we can come up with a very new type of data product that will go back to the reality, and the whole process will repeat again and again. Remember, decision-making process is not one-time activity, so we keep making decision and making decision, and therefore, this process is a circle that goes on and goes on and goes on in a circle. So what are the tools that we use to analyze data? We have two types of tools: auto-managed, or simply referred as closed tools, and then we have the programming languages. The auto-managed tools include Excel, Tableau, Looker, etc. These are tools that they come already designed, so we buy them from the vendors and we just start working with them. They don't give us the flexibility of being our own creator and design things the way we want. Another limitation they come with is that they don't allow you to use large amounts of data. Assuming you're working with Excel, in most cases, we will want to reference cells. You'd want to reference cells. So imagine a scenario where you have like 1 million rows. So you will be talking like column B, row 1 million, which looks funny. And then we have programming languages, which include Python, R, Julia, and SAS. And this gives us the flexibility of being our own creator. And also, they give us the flexibility of working with very large amount of data. For the sake of our discussion today, we will be using Python. What are the most common libraries that come with Python? We have Pandas, which is the cornerstone for data analysis. We have Matplotlib and Seaborn, which are visualization tools. And then we have NumPy, which is a numerical library that helps us with all calculations in Python. We have SciPy, and we also have sklearn that we are going to talk more about in the future slides. So right now, what I want to show is just a snippet of how you would visualize your data using Seaborn. And I am using Titanic dataset to illustrate this. Titanic is this big ship that in 1912 collided with a big iceberg in Atlantic Ocean and capsized. And so many people died. And so I tried to analyze, to come out with a count of how many people survived and how many people died. From this, you can already see 0 represents death and 1 represents survival. So it is easy even to tell that it is unfortunate so many people died and few people survived. In my right side, I have an analysis of showing how people survive per class. The people who are boarding in first class, others second class, and others third class. So we may want to check how did people survive per class? It is obvious that those who are in the third class really died. And as a stakeholder, as somebody in the cargo industry, you would want to ask yourself, what do I do so that even people in the third class are protected? What do I do so that this high level of death do not occur? So these are kind of the decisions that somebody may want to come up with. What do we really need to do so that in case of any tragic, we will save life, because we really do not want to lose people. And these are some of the things that data analysis will help us with so that we are able to make right decisions. Thank you so much, Dispa. Allow me again to welcome Monica to continue with us. Monica, welcome.
Thank you so much, Lucy, for taking us through the data analysis process and the tool that we use and all the libraries that make all the magic come together. So are we talking about, if you allow me, I will share my screen and I will go deeper into the 4 buzzwords or the 5 buzzwords that I had asked you to put at the back of your mind. And this is just to granulate what Lucy has already shown in that picture. So one of the buzzwords, or just to refresh your memory, there was the collection, the collecting, the inspecting, the cleansing, the transforming, and data modeling or modeling data. So what is data collection, and where do you get all this data? Like, where will Zoom, if they wanted to know the people who are on Zoom today, where will they get the data? So we have different sources of data. I'll talk about the structured first because, and then I'll talk about the unstructured. So what is structured? So with structured, you will at least, you don't have to put in a lot of work to getting your data in the form and shape that you need to load it into your integrated development environment. So some of the structured sources are databases, and I have listed a few databases that you can get data from. And then you can also get your data by consulting application programming interfaces. This is where you have 2 applications talking to each other. And you can also buy your data. And then you can also get your data from computer log files. So this is very common in the IT industry, especially when there's a security breach or anytime you would need, anytime a computer crashes. So the logs will help you to at least debug the process and at least come up with good feedback. So I also talked about unstructured data sources. So if I'm sure every one of us here has been to a website, today you went into Zoom just to get on this call, guess what? All those nuggets and the beauty that you see in that Zoom, Python has a way of getting all that information, and it can also be analyzed. And that's how we are even able to get the people who, I guess, are not talking or not following rules in websites like Twitter. So how does Python do that? It is by using libraries like Scrappy, Beautiful Soup, and Selenium, just to name a few. Now, for you to inspect your files, or at least for a good inspection to take place, and this is mostly for the data that you get in an unstructured format where you don't have the rows and columns well defined, you would need to put your data in file formats that can work in your integrated development environment. And what kind of file formats do we work with in Python? So we have the comma separated variables, which is a CSV. You have Excel, you have text files, there is the XML, which is extensible markup language, and then there is JSON. And Lucy walked us through some of the common libraries that we use for everything that is behind the machine learning and AI. So for this data collection and inspecting, what we do, we use pandas, and this helps to load our data into our environment that we do our development. And in my next slide, I just want to walk you through how do we actually load the data, and when data comes in this form, what do you do? So in the first one, we are loading data from a CSV, and you will notice, so there is the read CSV, that is a function in Python that helps with that. And then you can also get inbuilt data, which comes into your, it already comes in the Python delivered or the machine learning delivered websites like SNS, which is alias for Seaborn. It's something that Lucy talked about. And then you use pandas for reading all these files. And what you see here is PD for pandas. It is an alias that you give whenever you are importing data. So whenever, or before you use any of those libraries in your machine learning, you have to import them into your IDE, which is the integrated development environment. And then you can also get your data from Excel. So this is the function that you would use. And good thing, the beauty of it is that whenever you're given an Excel with so many sheets that have different data, you are able to go in and filter your sheet name or whatever you want to get information from. And you can also get information from websites. So this is more power to pandas. And apart from also just reading data into your IDE or into your integrated development environment, or you can also pull data out of it. I have worked with, I know Old Habits Die Hard, so their business counterparts that you work with, like, I don't know how to look at this data, send it to me in an Excel, send it to me in a CSV. So this is exactly how you do it. You send it to your CSV and share it with your business partner, or put in your whatever SharePoint or whatever link that they have. And then in my next slide, I just wanted to show you a snippet of how I started off with that Excel that I showed in the previous screen. And then this is the actual screen name, or this is the sheet name of the data that I had been provided. So at least I didn't pick up orders, I didn't pick up everything else. So I only picked up what I need. And so that's it about the first two buzzwords, which is collecting and inspecting. So I will now explain what exactly happens in data cleansing, which is the other buzzword in our data analysis scenario definition. So what is data cleansing? This is where we identify missing or empty data, incorrect data types, incorrect or invalid values, outliers, and non-relevant data. And then we also identify duplicates, because as Lucy mentioned, garbage in, garbage out. You don't want all these duplicates because you will get inaccurate predictions. And remember, whenever you're doing machine learning, you're dealing with people's lives. The kind of analysis you do is to impact people, and you need it to be as accurate as you can. So good data really helps in that process. So aside from the identification, we also do data imputation. So based on the algorithm you choose, you can decide to, or the algorithm either spells that you drop the data or you input data. And then you also do a lot of statistical sanitization. So when you think about statistics, it's any function in statistics. You look at the mean, the mode, the median, because you want to analyze all these factors and cleanse data accordingly, so you can at least get the target, or at least data that can help make decisions. And you would wonder, what exactly do we use in data cleansing? So back to the slide that Lucy mentioned, the libraries. So we have pandas, we have NumPy. there is Matplotlib and Seaborn that we use for visualization. And the Matplotlib and Seaborn, the visualization comes in very handy, especially when we are trying to identify the outliers, like the really odd ones out. So in my next slide, I will be showing like a code snippet of how do we even do everything else that I mentioned. So this is a data set that we got from East Africa Loan Prediction. And as you can see in the cell number 6, so we first went in and identified all the nulls, because one of the things that we said we do is we identify all the data that has empty. We don't want to use that. It won't really add any value to our training of the algorithms. So what you can see here, these are all the attributes that were in that data set. And I see we had 13 records that had no gender. We had this many that were not, or were married was left blank, on and on. And then we also use functions within Python to at least do a value count, so we can know if we are actually doing what we intend to do. So what we did here is of the 13 records that didn't have any gender, the trend shows that East African men have a tendency of applying for loans. More power to you guys. So what we did, we went in and filled more males, or whatever, for the 13 records that were missing data, we updated with the male, or male as a value. So if you look at what I have here on the number 8, so now we have 502 records, which adds up to 489 plus the 13 that were missing. So that is one, it's just a snippet of one of the things that you do. And for more information, or if you want to look further into this, yeah, you can sure connect with me on LinkedIn or GitHub. And then in my next slide, I want to talk about the fourth buzzword, which is the transforming. And what do we do in the transformation? So with our data cleaned, we are now ready to go and rearrange and reshape the data for better analysis. And then we also transform fields. And what do you do with transformation? So whenever you're doing machine learning, it is a general rule that at least you should have all your data in numerical form. So like the males, you can decide to make male as 0, female as 1. So that's what you do in the transforming. And then you also merge your tables. You want to work from one source. If you're given many sources, then you want to work with one source. And then there's also combining data from multiple sources. And then what is the objective of all this? The objective of this process is to get your data ready for the next step. And what libraries do you use? So there's pandas, there's NumPy, there's Matplotlib and Seaborn, if you have to visualize any of that. So what I have on my next slide is, how do we even merge the files? How do we make it one list that is easy to use? So this is just, this is sales data that we got, and those who are in business, you record your sales by month. So we have a total of 13 files. We have listed them using the os.list directory, which is a function within the os library in Python. And so once we know we have the list, then we want to bring all these files together. And how do we do that? So my next slide is just a snippet of how we do that. And yeah, we use a function in pandas called data frame, because data frame is a data structure which contains the labeled axes, rows and columns. And then you can also output your data. And to get all the files together, there is a concat functions. And as I mentioned, should you need further details on all these, we are available on LinkedIn and GitHub, and we are willing to be that mosquito in your room and just impact you in whatever ways. So the fifth buzzword in our description of data analysis is data modeling. And what is data modeling? So this is the process in data analysis where machine learning actually begins. And it involves extracting patterns from the data that is now clean and in shape. So you are fed with this many flowers. If you are in a biology lab, you feed them all to the machine. You tell them that equate to a rose if this is the petal length or the sepal length. And yeah, it is able to establish all those patterns and capture some trends. So, and machine data modeling also involves capturing trends or anomalies. And whenever you're doing your data modeling process in data analysis, it's very critical, or rather statistical analysis is fundamental in this process. And what library is used for this? We have scikit-learn, and you will see it denoted as sklearn for the most part, but that is a library that we use. So with that, I will share some of the popular algorithms that we use for machine learning. So we have linear regression, which is where we try and establish a relationship. A good example is how is weather or temperatures and the sale of ice cream related? People tend to buy more ice cream when it is warm and tend to buy less ice cream when it's cold. And then logistic regression is almost the same as linear regression, only that for the outcome in logistic regression, you either get, the results are binary. It's 0 or a 1. So you either have COVID or you do not. There is no in between. And then comes the decision tree, which, as the name suggests, it is a tree and it has branches. So a good example is if you wanted to know the kind of music or the kind of shows that people would tend to watch more, in a case of a company like Netflix, so there is the age that is a big factor, and you probably agree with me. So are you below 30? Are you male? Are you female? So with that kind of branching, there is a lot that you can get from that. And then there is a random forest, which is also an amplified version of decision tree. Think about a tree and a forest. And then we also have the k nearest neighbors. And what is k nearest neighbors? As the name suggests, it's nearest neighbors. And the common, there's a common jargon that goes around and says, show me your friends and I'll tell you who you are. And some of us growing up, you will, I'm sure you can remember, your parents told you if you hang out with those people, you end up like them. Same applies in k nearest neighbors. So what happens is we introduce a data point, and at the point we introduce a data point in an X and Y axis, it tends to lean more onto the kind of behavior that is displayed by the neighbors around it. So just to give a snippet of that, and again, if you have, you want to look into this further, we are available on LinkedIn, and we'll have our contacts if you want to reach out to us. So what I'm showing next is a snippet of how we actually achieve all this in code. And how do you do that? So as we mentioned, we use the scikit-learn library. And as I mentioned, you'll see it as sklearn. So what you're doing in this case, you're calling the library and using the dot notation to call the module within that library. And then you're importing the method, which is the logistic regression. And in case you're using the k-neighbors algorithm, then you would do the same and import the k-neighbors classifier. And then the decision tree, you would do the decision tree classifier. And then in random forest, you would do the decision, the random forest classifier. And you may be wondering what these are. So these are some parameters that are set for each algorithm. And for the sake of our audience today who may not be interested in getting into the weeds, if you need more information in that, we can definitely walk you through the code and help you understand everything behind all these things that you see here. And so without further ado, I will want to hand this back to Lucy, and she will take us through the next slides. And again, I just want to thank you for hanging in there with us. I hope you all enjoy this flight to Data World. Leslie, take it away.
Thank you so much, Monica. And our viewers, I still want to just thank you for being with us this far. I'm taking you through the last slides for the day, and I hope we are learning together. So I'll share my screen. Sorry. Okay, so I want to take us through the steps that I used to establish these trends. Already Monica has talked about loading data, and she has even shown us several ways of loading the data. And then she has also taken us through the cleansing and even the reason why we need to cleanse. So the next step after we load the data and cleanse the data is to split data into training and testing sets. After we split our data into training and testing sets and the patterns in our training set. After we train the model, we use our testing sets to make predictions. After we make predictions, we need to evaluate our prediction so that in case we are not getting the right accuracy, then we may want to improve the model so that we get better accuracy. So I want to take us through codes that are giving us a practical way of how we will split our data, create model, train model, make decisions, and even evaluate. So I will be using a heart disease data set, and I just want to try if we can predict whether an individual will suffer from heart disease or not, given some features which include sex, cholesterol level, and ECG level. So in this data set, which is the heart disease data set, every row represents every individual. And then in the target column, we are having one to indicate that somebody has heart disease and 0 to indicate that somebody does not have heart disease. The first thing we do is to select the features and the targets. So our features are the independent variables. They are the variables that we are using so that we achieve the target. So we have sex, cholesterol level, and ECG level as our features, and this goes into x-axis. And then we have our target as our dependent variable, which goes into y-axis. After we select the features, then we have to scale these features so that they are normalized and in a standard scale, because we don't want to compare apples with oranges or mangoes. So there is no relationship between a kilogram and liters. So the thing here is we use a standard scalar method, which comes from sklearn library, so that we scale our features to make them standard in a standard way or in a normalized way that are related and we are able to work with. Once we do these 2 steps, the next thing we do is now to split the data set. So we use train test split method that also comes from sklearn library from a module that is called module selection, so that we split our data. And we are splitting our data so that part of it are used for training the model and part of it are used for testing the model. So in my splitting, I'm using 80% to train the model and 20% to test the model. After the splitting, we train our model. And in this case, I am using decision tree classifier model. So we first of all import the decision tree classifier model, which also comes from a module called tree from sklearn library. And we assign decision tree classifier module to just an object called model. You can call it anything. I called mine model. And then in our training, we will use our features train. You remember our features, the sex, the cholesterol, and the ECG level, and then our target train. So what our model will be doing here is to study the pattern between the features train and the target train. And once it has studied that, we assume that it has learned, but we need to check that by now making predictions using the set that we splitted for our test. So we will use our features test split, and we will call on a predict method that is coming from our model to make predictions. So it will be checking like it trained, and then if we give it our features test, is it able to give us the right predictions? And this is what now take us to the evaluation. We want to like check, is it giving us the right accuracy? So we use the accuracy score method to test our target test with our target prediction so that we are able to get the accuracy. As you can see, my accuracy is 46%. This is not something you would want to go with. Remember, we don't want to predict that somebody has a heart disease when that person doesn't have a heart disease. So what we do is to improve our model. We will go back into the splitting and maybe use a bigger percentage for our training, or we may want to use a different model so that we leave the decision tree and maybe work with a random forest classifier so that we are able to come up with a good percentage in our accuracy. The other ways that are used to check on our accuracy. So they include, we can use confusion metrics, we can use a classification report, and we can use prediction. How does confusion metrics work to show us that our model is working correct for us and we can use it to make decisions? Confusion metrics is a table that will give us some basic information that I will explain. Here we have TN. TN stands for true positive. TP stands for true, TN stands for true negative. TP stands for true positive. FP stands for false positive. And FN stands for false negative. The model is giving us 5 as our true negative. So these are, this is like, it is testing 5 people who are actually having heart disease and finding that they actually have heart disease. But the model is also giving us 2 people who are not positive, but the model is predicting that they are positive. So these are people who are negative, but our model says they are positive. And then we have 4 people who are truly positive and they are predicted as such. And then we have 1 person who is not having heart disease, but the model is predicting that that person has heart disease. Our concern is to ensure that our true negatives and our true positives are higher values compared to false positive and false negative. And this is what we will check so that we are not giving wrong information or wrong that will kill people, that will mess up companies and mess up businesses. I also used prediction to check on the accuracy in the prediction of what kind of music somebody would love. And in this data set, we are using age and gender to check on what kind of music will somebody love. So we have 1 represent male, 0 represent female. So I want you to check with me. We have a male who is 20 years old, a male 23, a male 25, and they all love hip hop. But in this set, I don't know what a male who is 21 or 22 or 24 will love. So this is what I want to try and give as my test to see what kind of prediction I will get. So I am using again decision tree classifier, and I am feeding in 21 years old male and 22 years old female and passing it through the predict method of the model. And as you can see, the model is telling me that this man will love hip hop and this woman will love dance. And this is working pretty good. I want to show how the decision tree performs. So with that music genre data set, the first thing that decision tree classifier model does is to check on age. Is somebody less or equal to 30 years old? If that is false, then that person loves classical music. Decision tree is just like a tree that has got its roots and branches falling downwards. So if somebody is not in that age bracket or is greater than that, he will automatically love classical music. But then if that person, if this condition is true, then the decision tree model will check on gender and check, is this person a female or a male? If this person is a female, then this person will love dance or acoustic. But then if this person is a female, is a male, then you will love either hip hop or jazz. I also want to give a scenario where we are using linear regression to predict the sales of ice cream based on temperature. So as you can see in my plotting, the sales go high. So whenever the temperatures are down, the sales of ice cream goes down. And whenever the sales of ice cream is high, whenever the temperature is high, the sales of ice cream is high. So as a business person, you will know exactly when your ice cream, because you don't want to go to the market when nobody is there to buy your stuff. And this is why even analysis is important. And this is why machine learning is important, because we want to make the right decisions. You don't want to be found in the streets with gumboots when it is sunny and there is no need of you having those gumboots. The government wants to make right decisions in planning the future. And so if we get the right prediction, we make right decisions. And that is what we want to do in our data analysis. In my last slide, I want to give some key points that we really need to remember on this day. These key points include, number one, data analysis is not data analysis until you analyze the outcome and draw your conclusions. Your conclusion is not a conclusion until you communicate it, until you visualize it, until you produce reports that are used for decision making. And therefore, you really need to have good conclusion. Don't forget the accuracy. The next thing you need to remember is clean data is key to successful modeling. Remember the rule of thumb, garbage in, garbage out. The more data you feed the machine, the more efficient the model will be. I want to leave you with this quote from Benjamin Franklin. Tell me and I forget. Teach me and I may remember. Involve me and I learn. Thank you so much for being with us this far. We are now ready to take your questions. And as Monica informed us and informed all of us, we have shared our LinkedIn. We have also shared our GitHub. You can reach out to Jackie. You can reach out to Migot. You can reach out to me or Monica for any explanation that you may need that is out of the discussion today, or if you just want to get deeper and deeper into this. So let me say thank you, asante sana, merci.
Thank you. Thank you. Thank you, Lucy. That was absolutely amazing. Thank you, Monica. Your presentation was amazing. And as I've always said, this is not my field in tech. So how you have drawn me in and explained it from start to finish, it's sequential, chronological, it makes sense. Thus far, I feel that I've gotten several nuggets. So now I want to open it up to the floor. Guys, this is the time we can unmute ourselves, have a discussion, turn on those videos. If you wish to turn on your videos, please feel free. You have Lucy, you have Monica, you have Migot here to answer all the questions that you have on AI, machine learning, data analysis, all that good stuff. What questions do you have? They're here for you. So, you know, take it away. Do I have a hand up? Do I have anyone with questions? Anthony, were you looking to say something? Anybody? Questions?
Yes, I have a question.
Sure, Eugene, go ahead.
Yeah, sorry, I'm new here, and I think this is one of my very first time to be around here learning with you. Though I wanted to get to know more about an algorithm. I've heard it several, though when I hear it, I don't get the actual meaning of it. Yeah, an algorithm.
Sure. Between Lucy and Monica, who wants to take that question?
I can take a shot at that. So you want to know more about the algorithms, right?
Yeah.
Okay, so with the algorithms, that is what comes standard with Python that we use for the data modeling, part of the data analysis. And the algorithms come with all, like somebody always says, this is somebody's PhD, so it has been thought out. And once you go through the steps that are required of that algorithm, you will sure be able to get the output that you're looking for. Now, you may also wonder, so how would you even know what algorithm to pick from, let's say, the 5 or the many that are out there? I only listed 5 because those are the most common. They all depends on your data set. And as Lucy also mentioned, whenever you do your modeling with one algorithm and your accuracy does not predict exactly what you want, remember we are dealing with people's lives here, then you can go into the other algorithms and try and see if you get better accuracy. And we can give you more details about this. You can definitely connect with us, but I do hope that that has at least touched on what the question was. And Bigot, you can feel free to add your expert opinion or input on that.
I think you,
Maybe if I just add a little.
Can I say something?
Okay.
I'm just I'm somebody who's done a little bit of Python and Java. My name is Fenora, but I think that if you have a link that somebody can go into and look at how to start learning, algorithms was the most difficult part of learning the languages, because once you get the algorithm, then you can kind of figure out how to do everything else. I think it's very difficult to explain algorithm because it's like a math type of thing, right? And I think that it's something that maybe if you have a link that can help people learn to start understanding what is var, what is, those terms that come with algorithm, it's like a math. It's completely different. And as an introduction, I think, how do you explain that to somebody?
Okay, I hoping that you're done. I just want to add that an algorithm in machine learning is just a procedure that is run on data to create a machine learning model. So machine learning algorithm is the one that will perform that performs the pattern recognition, so that it helps the machine to learn these patterns. So an algorithm is the one that will be performing those pattern recognition. Like if you're, for example, giving the machine a dog to recognize and say that this is a dog, then the algorithm will help the model to like learn the patterns of where the ear is. And they are just rules that are designed to help in step-by-step problem solving. I don't know whether that answers you.
Eugene, is that a good answer for you, or you need some more explanation? We can take it off the air when you're ready. You can inbox me, I'll explain everything. And if you're interested, we can also loop you into some of the stuff Fenora is talking about. Because I mean, this could be over your head, but it's an overview of understanding what is involved in machine learning, artificial intelligence, and also in deep learning, to create some interest so that maybe one day, if you want to get into this, then you know what you're getting into. These two ladies 6 months ago did not know anything, and I'm saying that with a lot of respect. But as you can see, they really articulate what it's that they learned, and anybody can do this. And I mean anybody can do it if you put your heart into it. So you just have to sacrifice and make sure that whatever you do it with love. And they really did, with a lot of sweat, blood, and tears. Me behind their back. Yes, all right. Thank you.
If I just add to what Migat said, Fenora, I'm not so sure if there's part of your question that I think you were asking about the nitty-gritties about what is a VAR and all that kind of stuff, like just for people to know. I'm assuming you want to know what the methods are, functions, library.
Well,
like
yeah, because, okay.
What's the basic?
Right, because like when you go to like how do you get into an entry level job, right?
Yeah.
Once you learn this, I enjoyed the part of learning, and what he said is very true. Anybody can learn this. I did it in 4 months, and I learned Python, Java, and Mean. But I struggled with the algorithms, right?
So there's part of what you're saying that is not specific to algorithm. It's learning the base components that to me, let me just to give a background of why I'm answering this. My background is in software engineering. There's some basic components that one needs to know that translate across any language, any platform. And those are the building blocks of any language. And I think that that's what you're asking. I think this presentation was really good because, as Migot said, it's bringing you into the world and showing you what's possible. What you're asking for is just one step further, or a step that people would need to have to learn the building blocks of any language, the building blocks of any programming. You need to know how to loop. You need to know what's a variable. You need to know the procedure. You need to know what's a function. You need to know what are constants and things like that. And that kind of translates in any language. So those are just building blocks that I think you are asking, how would one need to, how would one know these things? And I think that's something that maybe is an opportunity of give people some building blocks of how they navigate through all these languages and platforms.
Right. And I think that's what I don't know, the question the guy said was more of algorithms, and that kind of made me speak up, but he's gone. I don't know where he is. He's not saying whether we've answered his question or not.
Yeah,
he did.
He brought up the algorithm. He brought up the algorithm. Is he still there? I don't know.
Hello?
Yeah, Eugene is, he must be.
Oh.
Yeah, he shared on the chat that he's.
Yeah.
Hello?
Yeah.
Hello?
Yes, hello.
Okay, I have a
So
question.
I'm gonna just let him maybe ask his question. Maybe I just kind of got into it a little more than I should have.
Okay.
So the question was like, so it was like algorithm. Like when I heard the word for the first time, it seemed a little confusing because I'd come in a little bit late. Though I tried to be, what I'm trying to understand is that it's something like a set of rules. Given I just wanted to know what it actually means, an algorithm, how it's applied.
Okay,
Yeah.
let me see if I can answer that for you. Now, take it for from this example. You want to cook, let's say, a meal. Okay, that meal could be rice. Okay, you have a set of steps you need to take to be able to achieve what you want, right? So you say, first of all, you need to be able to have that rice available. You need water, you need fire. And then, of course, you need other ingredients. Now, if you can put those in steps to be able to achieve what you want, you can write them down. Whatever you write down, in a layman's language, that should be the algorithm. The algorithm could be very specific to the kind of task you're trying to achieve. Now, in data science, we have for example, we have tools we use, and one of the tools we use is Python. You could probably be using other tools we have out there like R programming, or you could be using SAS. Now, the way you reach your goal determines what kind of algorithm you're going to use. The kind of problem you're presented with might not be equal across the board. Depends on the industry. It could be in manufacturing. It could be in, let's say, in transport. Now, whatever you come up with as a solution to solve the problem will be your algorithm. Now, if you're interested, we can go really into detail of what an algorithm will be. But algorithm is very specific to that kind of tasks. you're trying to achieve. If that can answer your question.
Oh yeah, thank you so much. Try to pick. Thank you so much.
Thank you, Eugene.
Hello, hello, Mr. Migot.
Yes, sir. Yes, John, go ahead.
Yes. Okay, I have a question.
Okay.
So from my earlier understanding about the explanation of the data analysis, AI, learning, they call them bars, but I want to call them key pillars of data analysis. That is collecting, expecting. Can you hear me?
Yeah, go ahead, please. Go ahead.
So they talked about the key pillars of data analysis. That is collecting, inspecting, cleaning, transforming, and modeling. From their presentation, they were just talking about the making prediction depending on the predefined data collected, like use the Titanic data sets.
Don't go ahead straight to the question, real quick.
Oh, so
go ahead.
For example, if you want to translate that into a practical environment, let's an example, you want to analyze the fish catch with reference to the weather pattern. So like, I just want a step-by-step procedure of how you can achieve that, so that you come up with the precise prediction.
Okay, so you see, your question is very specific to the fish industry. Now, one thing we'll have to consider, what is actually affecting the fish market, like what makes fish available. So those are some of the variables we'll have to look at. And do we have the data to help us? Is it the weather pattern? Is it the, let's say, the moisture in the air, or like, for example, the how warm or cold the water could be? If you have all those facts together, you can use Python, for example, with the Python libraries available, to be able to come back with some kind of solution based on what you want. Like if you use, let's say, logistic analysis, or you can go ahead and say, okay, I feed in my data. I would like to see if this is possible or not possible. Is it A or is it B? That's going to be like, is it binary? Is it 1 or 0? Or do you want to go on the scale of whereby you want to get the percentage? If I go 80%, then I know I'm good. Or if I go less than 80%, then I probably need additional information on that. So those are also available, but the more, like you're already in my advanced Python class, so the more we get into those, the more you'll understand the concept. Okay. So I hope that answers your question. You have to have the right data. The data has to be the right and relevant data for you to even be able to actually get any support.
Hello.
Yes, sir. Go ahead, Irungu.
Yes, thank you. Somebody talked about model evaluation. Can she say something about K-fold as a method of model evaluation? Then my next question will go to Migot. Lately, I've seen most of data scientists are combining models. Can you say something about it, model combination or stacking?
Okay, so when you have data, I mean, do you have a specific data in mind? When you talk of stacking, let's say we have a classroom of maybe 30 students, right? And then all these students are taking, let's say they are going to take a final exam, but we're gonna go ahead and group them into 3 groups, 10, 10, 10, right? And then you can say, we are going to give these students some kind of, let's say, reading material for them to be able to sit for this final exam. The final exam could be, let's say, a math exam, right? And then you are going to go ahead and at the end of the day, you are going to go ahead and check their scores. Now, the group A, we will have to get their total average. Group B will have to do the same, and then group C. And then at the end of it, then we get the standard deviation, for example. And then based on that data, we are going to go ahead and maybe stack them all together. And then we do the analysis. Now, whatever you're trying to do with your data will only be determined by what you're trying to achieve, as in the conclusion. How is it going to affect, say, the school administration, so that they know, hey, is this a good learning method, or can we make changes to it? So when you say the K-fold and the model evaluation, it's really going really deep into beyond what we can cover within this particular hour. But if you need more information, feel free to reach any one of us. And of course, we'll be more than glad to assist or to actually have some kind of kamkunji whereby we can discuss more. Is that okay?
Okay, that's good.
Thanks, sir.
Maybe just a final confirmation, yeah?
Yes, sir.
Can you say that a model combination performs better, or is a good thing from your own perspective, maybe?
That's gonna be really very, very tricky question. Performance depends on what kind of data you get. Is the data clean? Did you clean it right? Could be a clean data, could be not very clean data, but you have to be able to actually clean your data and then be able to model that data so that you can get something out of it. So I really cannot give you an answer off my head. You know, for example, if I go into the IEBC data set for, let's say, the elections in Kenya, I might not be able to get what I'm looking for. But if I come, let's say, to the US, I get the data set, say, for, let's say, a state in, let's say, in Washington state. Then I know there was some kind of, let's say, some kind of a control, you know, put into the collection of that data set. So there was less of human manipulation to favor one aspect of it or the other. So that's just an example. So I really cannot tell you for sure off the bat unless I do some mathematical or some kind of evaluation to be able to come back to you and tell you for sure, yes or no.
Okay, I think I'm satisfied.
Thanks, sir.
Okay.
I have a question. Well, actually, two questions. My name is Irene. So you said that Lucy and Monica didn't know much 6 months ago. So what steps did they take in 6 months to get from 0 to 100? And then the second question is, for someone who's already gotten the skill, what would you advise them about getting jobs in that field?
So I'm going to go ahead and answer part of that question, and then I'll also let Lucy and Monica speak for themselves. So when we first started, I offer Python programming, introductory part of it for free. Okay. So when Monica and Lucy, I don't know how they got hold of this wind and they came in. Apparently, Monica, she has her own thing going, like she's been in the data industry for some time, but she decided to come in and get this aspect of data science and Python programming. Lucy has been in the industry for some time. And that, to some extent, I would say probably gave them a fair advantage. But again, it also depends on the personal sacrifice. These ladies, they are like a world apart. Lucy is in Kenya, in Kisumu, and Monica is in Atlanta, Georgia. By the time I go to bed at 3 in the morning, they're waking up and they catch up on what they need to do. So, like I say, blood, sweat, and tears. So it's grueling, but I'm not trying to say it so to scare you, but it also depends on your personal sacrifice. If you already have some element of, let's say, some knowledge in, let's say, in programming or in the computer industry, I would very much say you're already like halfway there. You just need to put a little bit more effort and don't miss the classes, because I take the class. Last time I did the one for 40 days. The first one I did was for 30 days. So Lucy and Monica were in my class, which was for 40 days. And as you can tell, that really helped them a lot. And then after that, they came into my advanced class, which lasted 3 months. And of course, in between, there's been a lot of things which are going back and forth. But again, I have to say, I try to really push. If I can, I push, but respectfully, so that they can also get whatever they need to get out of the class. But I'm gonna go ahead and give it to Lucy and Monica to also put their word in it, so you can get to see their perspective. Go ahead.
So Irene, that was a great question. And the one thing that I live by, nothing is impossible to the willing mind. So, and I will use this answer to also answer somebody who had asked if they have no tech background, no data science, or no computer science background, how do you even get from 0 to wherever we are? So as George said, there is hard work involved. And I guess it was RM who asked, yeah, I don't even have a degree in computer science. And better yet, 6 months ago, I could not even write Python, but I just decided if it's there and people have done it, yes, I can do it. So Lucy and I have the advantage of having Lucy on board because she's already a programming instructor. So she has helped me along the way, and I've shared my data background with her. So if you set your mind to do it, there is nothing that will stop you. Just dedicate the time. And yeah, and I know this is not really important to mention, but at the time I joined the class, I had a 1-month-old baby, and I've done it. And being in the US where there is no care, I do it all. So just give it the hard work, commitment, and as George said, do your homework, come to the class, and yeah, identify that person that you can work with, and it is going to pay off. And I don't know if Lucy wants to add on to that, because she's been the one waking up at 1 a.m. because the class is at 5 o'clock in the US. So she's been waking up at 5 a.m. and staying up until 4 o'clock. So Lucy, give your input on that. If you have anything.
Thank you. Okay. Irene, thank you for that question. And first of all, I'll say that we had a very humble teacher, tough at the same time. He wanted results. So he would teach us, he would give us assignments, and we need the results. A student would say, this is tough, but for us, we decided to go by the rule that our teacher is not just our teacher, he is like our employer. And when you are employed, you have to give results. So we would work out. Monica will be waking up most of the time by 4 a.m., 2 a.m. We had another person who also would be waking up very early, and we would try. Sometimes I would go the whole night because we have to do it, and it is just 3 months for the advanced class, and we had to learn all this. So first of all, it takes your passion to know something, and then your determination, and you really have to give it your all, because if you have to learn, then you have to learn. We know that most people have done it and they have achieved. So we decided that we really have to achieve because this is something that we really wanted. Another thing I would say is that Monica was coming in as somebody who was totally new with programming, and I was coming as somebody who is very new in the data industry. So the two of us would really complement each other. I get her through the programming part of it, and she gets me through it, and so we would complement each other. We also decided to like come up with a group discussion where we will work even when our teacher was not there. So these are some of the things that really motivated us. And I will tell you for sure, it has been months of sacrifice. Those who know me, all the time I am on Python.
Oh, did we lose her? I had a question.
Go ahead, Fenora.
Hi. So what is the next step from here, and what are your expectation and fees? And I mean, like, what is your program?
So the next step, as in Lucy and Monica, or the next step for somebody to come in and get started?
If somebody wanted to sign up, what happens? Like, what are your fees, and what is the first step once you get into the program, and how long does it take? And yeah.
So normally, what I advise very much is I try to take an angle whereby I would like to know my student, like to know what they are expecting. For example, I know you said you've done Java and you've also done Python, right?
Yeah, I took a program for, it was very extensive. Like, it's very, like what she said, it takes a lot. It took me about 80 hours a week, and I learned 3 languages in literally 6 months, right?
Well,
And
that means you're drinking from a fire hose.
yeah.
So I
would love to go back and just kind of like, I mean, I enjoyed every one, but it was literally 1 month you're learning something, and then the next month and you're using that. And most of these languages, if you learn one, you can kind of use it with rest. Okay. And like I said, the algorithms, once you learn the algorithm, is kind of like the biggest part of it, right?
Yeah, so let me just walk you real quick through that. The way I will do it, I will not rush to the end. I'll try to make sure that I cross my T's and I dot my I's. So by the time you're done with one language and you master that language. If you just want to finish the letter, you write one whole full stop, but you don't dot your I's and cross the T's, we're going to come back and start trying to edit again, and that's going to take a lot of time. So in the way we do it, I did with Monica and Lucy and their team. We made sure, first of all, I brush their knowledge of Python programming for at least 1 good month. And then based on that, I was able to give them an evaluation. And then before I even allow them to join the advanced class, I basically grill. I say, like, is this what you really want? Because it's going to be 10 times harder, if not like more work to be done. And then that's what they picked. So in advanced Python, we now started getting into databases, getting to AWS, as in Amazon Web Services. We also do Linux, like the command line. So I taught them all that. And then by the time we got into the munching of that data set and be able to actually make sense out of it, they were already familiar with what it takes. And almost it was becoming part of their routine. So for somebody who is coming in, I would probably say you can reach me personally or inbox me. All my information are going to be out there. And then I can walk you on a personal journey. So personal journey, I mean, not all clothes will fit in. I have to be able to evaluate your understanding, and then I tell you exactly what we need to do to get started. And I'm not saying I'm dismissing anybody, but your level of understanding could be very high than maybe somebody else. So I need to understand that, and then I need to be able to guide you so that we can all be on the same page.
Okay, so I have a sister that is within this group, which I think Irene, and so that's why we are all. She's not done it before, and I have had that, but I've not gone anywhere with it. So I would like to get back into it and sort of do something. So that's why we want to ask, like, what would be the next step? Like, what would be for her if she wants to go ahead and start this program?
Okay. All right. So I'll be more than glad. Oh, Jackie is also available if you're in Facebook and all that. So I'll be more than glad to like give you one-on-one so I can guide you guys and see how best we can do it together.
All right. I appreciate.
Thank you.
What I'll do is I'll drop my digits on the chat, and you can just hit me up, and then I can schedule something based on Migot's availability so that he can see then what works best for you and for Irene. So I'm just gonna put my cell number on the chat, and feel free to send me a message.
Okay, appreciate it.
Thank you, Fenora.
Thank you.
I just wanted to say thanks, Lucy, Migot, and Monica. I've been so intrigued by such a presentation. The data has been presented so simply and very well. I'm really encouraged to actually take it up and see how to do it. So it's something worth following through. I just had one comment about now that we are looking into the world of big data. I don't know what your thoughts are when it comes to streamlining, for example, in the in the hospital industry. People write a lot of notes on paper rather than using electronic health data records. I don't know what efforts you're making, because I see you're really intrigued in data analysis to strategically come in and streamline these kind of things, because I could be somewhere in, let's say, Meru District Hospital, writing on a piece of paper. Somebody else is in Aga Khan typing in diagnosis with the ICD-10 codes. And if we want to gather data for our country in general, you need data to be feeding in into one particular source with the same with the same standard of entry. I don't know what your thoughts are in terms of that, because I feel already in our country we are marginalized in some ways, and the resources may not be well distributed. I don't know what your thoughts are.
Let me see if I can answer you on that. Your name again, please?
Sami.
Sami. Okay. Thank you very much for the question. And I might be biased on answering that, but I'm just going to give you my part of what I think. First of all, I live here in the US, okay? And there are laws and regulations, especially when it comes to personal data. Okay, I'm not really sure about Kenya, but I remember my mom was sick not long ago, and I could get like handwritten notes on like vital signs and all that. That's almost something you don't see over here. And personal medical data like that are very much protected, just like your personal information. So we cannot say how we can come in and revolutionize the world, but Kenya has to have a way of putting some kind of like regulations in place to be able to have some kind of standardization. You know, Meru Hospital might be doing it differently, but if you go to, let's say, Nyanza or Aga Khan Hospital, they might be also doing something different. So it will take it takes a whole country in terms of those politicians.
Regulations, okay.
Yeah. So if they did that, then it would be fantastic. For example, the internet has been around for a long time now. Some of the people who were born just around the time internet started are probably married, and some of them are probably even grandfathers. But you go to some parts of Kenya, the internet availability is still very spotty, you know. So internet, and I would say specifically data, is actually, like they say, it's the new oil. You know,
it's true.
yeah. So without the internet, how are you even going to be able to get that data? Without the tight legislation, how are you going to get things all in one standardized format? So it's very hard. But I'm going to leave some people if they have a different opinion. But that's just my opinion.
Yeah, because I think, just basing it on Lucy's presentation and Monica's presentation, the more data you feed an algorithm, the more you train it. So you can imagine if 1% of the country is doing good entry and 99 is giving us paperwork. I mean, we cannot say the Kenyan population survives COVID more because of X. The population we are really studying is really small. I mean, it was just a thought, just to think about how maybe looking into the future, if there are any people on this call who are on those administrative lines can look into pushing into that agenda into the world, that would be great. Thank you.
Thank you, sir. Okay. Any other question, please? This is a good session. We're learning together.
No more questions from the people on the call. Migot, allow me to maybe read a couple of comments.
Please.
We have one from Pauline where she says, thank you to everyone. This was a great presentation. Mr. Migot, thank you for making yourself available to teach these two great minds and for being an influencer. We also then have somebody, Pauline again, who says, excellent, you guys have also taught us something. When you want something bad, you go for it. This also explains why it's important to identify your tribe. Great lessons, sacrifice, team effort, determination. Awesome. If I did not understand Python, I learned that it's important to follow your dream. And then there's also just picking random comments. Guys are looking to share their GitHub accounts and LinkedIn accounts. So people, please feel free to use the chat functionality to share, your contact details as you would like. And then Pauline again says also, on behalf of the people who are completely new to this, I must say that Lucy and Monica made it very interesting and relatable to day-to-day life scenarios. My takeaway is that we are all teachable, and I got a lot from this. So thank you for doing this. So I just wanted to read out a few of the comments for the ones who haven't been following the chat to see what's going on. And it's beautiful that Monica and Lucy, you guys made us feel like do this too, and then truly understanding your journey and the sacrifice it took, and having the people sitting in here knowing that if they really, really, truly want it bad enough, it's nothing possible. And the fact that you were in different countries, different time zones. Another beautiful thing that I'll just say, as a Black woman, it is nice to see women fighting to get in tech. Black women, I'm just gonna represent that part. And there are not that many. Sometimes we walk rooms where there are only men, sometimes not men, so it's just good to get the fight going. And we see what it took: sacrifice, dedication, determination. And that's not from an inclusive perspective. I mean, everybody, Black, white, candy stripe, whatever the case may be, masculine, feminine. If you really, really want it bad enough, then you put in the work, chances are high that you get it. And then also when we talk about tribe, and then when you ask what then happens to Lucy and Monica from that part, there's also the tech industry, and how are people sitting in this industry? How are they getting the jobs? How are they networking? It's important then to have that tribe behind you. Sorry, let me mute here. There you go. It's important then to have the tribe behind you. So I'll say what Claire and I do then on the back end is also looking at the resumes. Like you've come in, this is where you are right now, take your classes, that's amazing. Okay, then after that, how are we presenting you to the world? You know, how are your interview skills? How is okay, I've muted them again, but what I'm trying to say is how are you presenting yourself to the world? Because you could have the knowledge in your brain, but then you cannot articulate it well. And if you're not able then to articulate yourself or present yourself well, I may have to actually, okay, there you go. You're not able then to articulate yourself well, and you're not able then to present yourself well, everything is gonna remain here, and then what, you know? Because when you get this information, you're supposed to do something with it. So it's also, even in this day and age, it's understanding that a lot of the things are based on video conferences. So it's how are you showing up on video conferences? Are people hearing you? Are you speaking up? Are you interacting? Are you asking questions? Are you being a contributor? And all those things go a long way as well.
Yeah, right.
I'm going to actually take this person out because okay, we tried, right? We tried to keep them on for a little bit, but Migot and Monica, I'm gonna hand over to you. And if no one has any further questions, then we would maybe a closing statement from Migot, Monica, and Lucy, and then we take it from there. What do you guys think?
Yeah, I think that's a good idea. Let me just iterate one thing which you mentioned, which are kind of like forgetting, but I think Fenora probably also asked it. Now this aspect, not only your experience in programming or in finishing this will be able to help you. This aspect of you also need to be able to articulate your experience to your potential employer, and also create networks, be able to be out there so that you can be visible. One way we're doing that is to help those people reach out. You don't necessarily have to be one of the students, but of course, Jackie and Claire, they've really been very gracious to help us in that respect. They help with your resume. They also help you with potential interview questions and how to approach and be able to answer those. So those are some of the benefits we have. We are some kind of small, tight-knit community. All we're trying to do is to help each other so that we can be better and also remain competitive in this market. Okay. So as you know, the more we come together, the more we trust each other, the bigger the network it is, the better for everybody. Okay. I'm gonna go ahead and pass it over to Monica and Lucy. You guys can also put your sense in it before we close. Okay. Go ahead, please.
Monica, should I go first?
Yeah.
Okay. Thank you, everyone. I want to say that it is really humbling to see you having stayed with us this long, and even to read the comments that have been put on the chat, just saying how great it was. We don't take this for granted, and even for you having accepted to join into this call, it would have not been good if we found ourselves just the four of us. So thank you so much. I'm humbled. And once again, thank you, Jackie. Thank you, George. Thank you, Monica. God bless you.
Thank you.
Yeah, thank you so much, Lucy and Jackie and George. I mean, you have been our inspiration throughout the journey. And to our audience, I will not take this for granted that you tuned in just to at least share with us or allow us to be that mosquito that will supposedly make an impact in your life in a way or another. And just even listening out to us and giving us time to express ourselves, we don't take that for granted. And we have shared our information out there. Should you need to get in touch with me or Lucy, we'll make our LinkedIn profiles available for linking in with us. I believe somebody said that they require I think, premium subscription. You can send us your in mail or in name on LinkedIn, and we can connect with you. So feel free. We are here. We are an open book. We believe in the saying that a candle loses nothing by lighting another. Let's come together and make this big community that will be unbeatable. So God bless you. Thank you so much for tuning in with us, and happy Valentine's to all.
Thank you, Monica. And I think with that, I'm gonna
happy Valentine, everyone.
Jack.
Valentine. All right, guys. And with that, I'm going to say goodbye. Thank you so much. And then we'll see you on LinkedIn, on GitHub, on the Facebook community page. Remember, we have that page going as well. So feel free to jump on that. And it's your page as well. So if you have also things that you'd like to share on the page, feel free to use it because it's really for networking. So see you, and looking forward to all your success stories. Take care. Bye-bye.
Thank you, everyone, for coming.
Thank you.
Thank you. Goodbye.
Bye.
You see, you all nailed it. You guys did a good job.